Hi everyone, welcome to G World of Academic Physics. Today we will discuss one more application of electric field when an electric dipole placed in a uniform electric field. When an electric dipole is placed in a uniform electric field, it will experience a torque. Let me draw what is the scenario. Suppose this is my uniform electric field. I said the field is uniform. Uniform means the field is not changing with respect to time. This is my uniform electric field. And this uniform electric field, I situated a dipole. And this dipole, two equal and opposite charges, separated by a small distance. And I said this distance, suppose this distance is 2a. So what will happen? This is positive charge, and positive charge electric field is this direction, so definitely this charge will experience a force this direction. This is negative charge and field is this direction, so definitely this negative charge will experience a force this direction. So how the scenario I will draw? This scenario is like this. This is my dipole, positive and negative charges. And this positive charge will experience a force like this, and the expression of the force is Q into E. And this negative charge, if positive charge will experience force like this, so definitely negative charge will experience a force like this, and the expression is minus QE. If someone will observe very fundamentally, one can think this force this direction, this force this direction. The net force on the system, or you can say the net force on the dipole, is 0. But due to this couple of force, one torque will be generated, and this dipole is free to rotate. This dipole is free to rotate about its center of mass. This is very fundamental things. So one can remember. I want to make a conclusion also. If the net force on the system is 0, the net torque of the system is not 0. One can here observe the same thing, that if the net force on this system is 0, this force is this direction, this force is this direction, net force on the system is 0. But this net force system is 0, but the net torque of the system is not 0. Due to this equal and opposite forces, the couple of the forces, one torque will be generated, and this dipole is trying to rotate about its center of it, trying to rotate this directions, you can say, and I will consider this angle is theta. Suppose this dipole makes an angle theta with respect to electric field. Look at the point of the center of mass. If the length is 2a, exactly the center of mass is a point, and this is the point of center of mass I am considering. This point is a, and I know the expression of the torque. The torque expression says tau equals to R cross F. That can be written as R F sine theta, or that can be written as R sine theta into F. That is, one can written also R perpendicular F. So what I will do, I can say the component of the R which is perpendicular to F. The component of the R which is perpendicular to F. If I will find for the torque about this point, I am giving a name, just giving a name at this point. A is suppose a point. If I will write torque about point A, torque about point A, so what I will write at this point, the torque is due to this force and due to this force. And what is the perpendicular distance? This is the perpendicular distance. This perpendicular, if this is A, this angle is theta, so definitely this is A sine theta. Similarly, if this is force, this angle is theta, so definitely this is the perpendicular distance. And if this angle is theta, so definitely this is A sine theta. So what is the net torque expression at the point A? This is QE A sine theta plus QE A sine theta, because This is very clear. Force is QE, A sin theta. I am talking about, and both the forces, if you observe, this is this direction giving rise to the torque. Here the torque is into the plane, and you can say this is clockwise torque and produces the direction of the torque is into the plane, and in this case also direction is into the plane. So that's why both the torque will be added up. And what is the direction? Direction is into the plane. I can say minus k cap. I can write like this. It means if this is x, this is y, I'll say the z direction is into the, z direction is outward is positive. I said the inward is minus k cap. So what is the expression is coming? This is 2QE sin theta. 2Q, and another thing is 2QA E sin theta, and direction is minus k cap. Also expression, this can be written as 2QA. This whole things can be written as dipole moment. So this is PE sin theta. This is minus k cap, because inward direction I have assumed minus k cap. So torque about the point A, this is P sin theta. So the torque is nothing but P cross E. This is the basic definition. A student must have to be in the mind that what is the torque experience. The expression of the torque is PE sin theta when a dipole placed in a uniform electric field. One more time I want to repeat for the student perspective. What I have done, I have considered a uniform electric field. In this uniform electric field, I placed a dipole having length 2a, two equal and opposite charges, and this dipole subtended some angle theta with the uniform electric field. And this is pretty clear. These are the two opposite charges, so that's why these forces are opposite. Due to this, we concluded one important thing, that if the net force on the system is 0, the net torque of the system is not 0. Due to couple of forces, the torque has generated. Due to this torque, the dipole trying to rotate, and what will happen, this dipole is trying to align along the direction of the electric field. The dipole will trying to align along the direction of electric field. Due to that, torque will be generated, and I know the definition of the torque, that tau equals to r cross f, that giving rise to rf sin theta, that is r sin theta into f, that is equals to r perpendicular f. So what I will do, I will break the component of the torque. I will break the component of A, which is perpendicular to the force. So similarly, this is A sin theta, which is perpendicular to F. Again, I will break the component of A, which is A sin theta, which is perpendicular to F. So what will happen? This torque is, this is clockwise torque, this is also clockwise torque. So both the torque will be same direction. I will simply add it up and reach to a very heuristic conclusion that tau equals to P cross E. That student must be added in the checklist. Second most important thing that student has to be in the mind, work done. What will be in the mind? Work done. Let me think about it. This is my uniform electric field. This is my uniform electric field. And in this uniform electric field, what happened? A dipole was initially like this. A dipole was initially in a uniform electric field, minus q plus q, a dipole. In a uniform electric field, a dipole has placed. What is due to this electric field? One torque will be generated, and this dipole will trying to rotate along the direction of the field. What will happen? This dipole will trying to rotate along the direction of the field. This dipole will trying to rotate along the direction of field, and it is free to rotate. So if I will consider about the moment of inertia, I will consider the momentum inertia about the center of mass of the dipole, because it is free to rotate. It has not hinged or pivoted at any point. This is also an important thing that student has to be in the mind. What will happen? I little rotate the dipole. Initially the dipole having some situations. What happened? I simply rotate the dipole. A small rotation I give to the dipole. Suppose now dipole is like this. For a small d theta rotation I did in these directions, what will happen? It will make some work, because work done due to electrostatic, what will happen is very carefully one has to be think about it. Initially the dipole was like this. What happened? I'll little trying to rotate the dipole like this. Due to electric field, this dipole will come down to like this, but I rotate it like this, d theta. If I'll go for my work done due to electrostatic work done, this is nothing but tau d theta, because work done definition is nothing but what? Tau force dot displacement. Here angular displacement d theta have done here, tau d theta. Work done equals to tau d theta. What is the angle between tau and d theta? The torque direction is like this. It means clockwise torque will be generated. It is what kind of torque will be generated? Clockwise torque will be generated. And what is the direction of the clockwise torque? Downward. And which direction I have rotated? This direction, which is upward. Torque is clockwise. I have rotated it to be anti-clockwise. So tau d theta angle is 180 degree. So tau d theta cos 180 degree. This is the angle. And this is pretty clear. This is minus tau d theta. This is the work done. And what will happen? I know the expression of torque. The expression of the torque is Pe sin theta. And this is d theta. And I have done a very small work done, because I have rotated a very small angle d theta. So can I say this is a very small work done I am talking about? Yes, this is a very small work done. So this is minus dw work done, you can say. If I will go for integrations, then I will get the net work done. So this is nothing but the integration of what? P sin theta d theta. If I will put my initial conditions, that initially dipole having, if I will assume that initially it is in theta 1, now it is theta 2 positions, then what is the expression of integration of sin theta? The integration of sin theta is minus cos theta. So expression is coming Pe cos theta, because sin theta integration minus cos theta, here one minus giving rise to plus. The expression is coming Pe cos theta, this is theta 1, this is theta 2. And this is what is the expression is coming? Pe cos theta 2 minus Pe cos theta 1. This is a very fundamental things, that work done we are getting. The work done due to electrostatic. The work done due to electrostatic, what is the expression is coming? That is work done due to electrostatic, Pe cos theta 2 minus Pe cos theta 1. Now important thing is, we know the work done due to electrostatic is negative of work done due to external. So using these things, can I say this work done is nothing but due to electrostatic is nothing but negative of potential energy, and this can be written as what? U initial minus U final equals to, can be written as Pe cos theta 2 minus Pe cos theta 1. This is very important thing the student has to be in the mind. Work done due to electrostatic is negative of potential energy I can write, that is U initial minus U final. This is P cos theta 2 minus P cos theta 1. If I will assume that if I want to go for a work done due to if I will go for work done due to a specific, I have to make it this, someone has to be 0. So one has to be assumed that actually there will be no potential, single potential at any point, there will be a potential difference. We assume one point to be 0, and that is treated as an infinite potential is 0. Similarly, if I will assume that UF is 0, I must consider that theta 2 is 90 degree. I must consider what? Theta 2 is 90 degree. The dipole has 90 degree has base. So in that case, what I will consider, that potential energy is nothing but what? Minus Pe cos theta 1. Potential energy can be written as what? Pe cos minus Pe cos theta 1. This is very important thing. make it to be more generalized for the student perspective, one student has to be remembered that u equals to minus p dot e. This is a very important thing that a student has to be in the mind when he is thinking about to solving the questions of the work done. Let me one more time to for the student perspective what I have considered. If I will place a dipole in a uniform electric field, the dipoles will trying to rotate along the direction of the electric field and trying to align in the direction of the electric field. If I will displace d theta in the opposite directions, then what will be the work done? Work done is tau d theta, a very small work done I am talking about. Tau and d theta angle is 180 degree. So due to that, the negative sign will be a dot b can be written as ab cos theta. So tau d theta is coming. So minus p sin theta d theta. If I will go for the integration, I will get the net work done. If I will say initially dipole as theta 1 and finally it is theta 2. So p cos theta 2 minus p cos theta 1. This is the work done. And I know the work done due to electrostatic is negative of potential energy, and due to that u initial minus u final. If I will go for potential energy for a specific, always there will be a potential difference. But if I will go for a specific point, then I will make it one of the thing is to be 0. I simply make it 1 0 by assuming that theta 2 is 90 degree as a base. So I will get the expression of potential energy that u equals to minus p dot e. This is very fundamental thing that student has to be in the mind when solving this kind of questions. I will do some of